All right, class, so here's the explanation for Sapling question number 17. I've already jotted down a few, starting points from the actual question. If you look at the question, it says a solution of household bleach contains 5.25% sodium hypochlorite and NaOCl by mass. So I went ahead and just wrote that down. I don't necessarily know at this point in time how I'm going to use that information, but if it's given in the problem, it's probably important. So that's the first thing I'm going to sort of jot down. The next sentence says, assuming that the density of bleach is the same as water. So here I've written the density of bleach equals 1 gram per milliliter. So I just know that that's the density of water. If you had to look that up, that's totally reasonable. Then it says calculate the volume of household bleach. So since that's the end goal, I've written the volume of bleach at the top with a box around it. That should be diluted with water to make 500 milliliters of a pH equals 10.1 solution. So pH equals 10.1, and then I could write 500 milliliters solution as well. So, now I sort of need to start working towards solving this problem. At this point in time, when I was doing this for the first time, I did not have, the whole procedure all laid out in my mind. Basically, I just started working towards, something and having these things in mind with my end goal in mind, trying to put things together. So the first thing that I notice is that we're talking about sodium hypochlorite. And that looks like a salt. So if I put that in water, I expect to form sodium plus and OCl minus ions. And the next thing I would think to myself is, well, do the hydrolysis reactions occur? Will either of these ions react with water? The sodium, I think we've seen enough that will not react with water. That would form a strong base in the case of a hydrolysis reaction. So that's not going to be the one we're concerned with. But OCl minus will in fact form HOCl plus OH minus. Now I'm writing this down. This is a hydrolysis reaction, and I see this OH minus, and I know that that means that this is a Kb type equation. I don't know what the Kb is yet, but I am recognizing that this is a Kb type equation. I do know, however, that the Ka for HOCl for my conjugate acid here equals 4.0 times 10 to the minus 8. All right, so this information, if you click on the hint, it tells you, how to look this up. So if I know the Ka for HOCl, then I can solve for the Kb for this conjugate base, OCl minus, simply by taking 1 times 10 to the minus 14 divided by the Ka value, and that equals 2.5 times 10 to the minus 7th. So that is going to be my Kb for this equilibrium. Okay, so making some progress, that's good. I do not know what my initial concentration is, but I do know what my final concentration of OH minus is, right? Because of this pH information, that allows me to solve for my final concentration of OH minus. If I fill out this ice table, I know that I can solve for X, so the way that I would do that, I would say, well, if pH equals 10.1, pOH equals 14 minus 10.1 equals 3.90. And then my concentration of OH minus, that's going to equal 1.26 times 10 to the minus 4th, right? And that's going to equal my X value. So now I can go ahead and start, putting things together. Where I've simply inserted this X value into all the places where I should find X, and I can solve for my molarity, which is going to equal 0.0635 molar. And that is for OCl minus, right? Okay. So at this point, this is a good point, and really this problem here, I would say, is definitely a reasonable thing for me to ask of you. I think this is, something we've done, basically finding the pH of a salt solution, finding the Kb from the Ka. All of this is stuff that we've sort of done before. And this last part is a little bit of the, problem-solving aspects that I was talking about earlier. It takes a little bit of cleverness to put the last part together. So in my mind, what I was thinking about is I said to myself, okay, if this is my molarity, right, that's my moles per liter. So I could say 0.0635 moles per liter of OCl minus. I can multiply that by 0.500 liters, right? I know that's a 500 milliliter solution, so my volume should be 0.5 liters. That's going to give me my number of moles of OCl minus that I need to put into the solution, right? So that equals 0.0318 moles OCl minus. And, being able to sort of figure out this last part, it is definitely tricky. It's not easy. Experience working problems is going to help you sort of decide to do this, but also, especially when you're starting out, sometimes you're just going to sort of guess and say, well, this is something that I could do. Is it useful for me to have the moles of OCl minus? Is that still pushing me towards the final answer here? And that's okay, right? You're gonna go down paths sometimes that don't lead you where you want to go. But I would just encourage you to keep going, right? If you get to a point and you're sort of stuck, go back and see, are there other pathways that I can go down? Now, once you are done, that's when really the studying begins, right? So once we finish this problem, then what I want to do is go back through the entire problem and say, why did I do this? Why did I do that? And sort of get through the problem that way. All right. So anyhow, to finish off this problem, if this is my number of moles of OCl minus, I know that that's going to equal my number of moles of NaOCl, right? It's a 1-to-1 molar ratio. Up here I've got NaOCl dissociates Na plus OCl minus. Same thing's going to happen here, so sort of in opposite direction. The next thing I'm going to do is I'm going to figure out the number of grams of sodium hypochlorite that I would need, and I just looked up the molar mass of sodium hypochlorite, and that gives me 2.36 grams. And now the last step is to use this density of bleach and this information about, can't see it, density of bleach and the 5.25% by mass information to sort of figure out, okay, how do I get 2.36 grams of sodium hypochlorite? So let's go back up here. 5.25% by mass, another way to say that would be that in 100 grams of bleach, we would have 5.25 grams of sodium hypochlorite. Or we could write that 5.25 grams of NaOCl is going to be in 100 milliliters, right? Because we're using the density of bleach in 100 milliliters of solution. So this information here, that's what I'm going to need to use to finally solve this problem for good. 2.36 grams NaOCl times 100 milliliters over 5.25 grams. Here I'm just using this sort of as a conversion factor. Again, this means in 100 milliliters of solution, I will have 5.25 grams. And I'm going to use this sort of conversion factor, cancel out my grams, to figure out the volume of bleach that would contain 2.36 grams of sodium hypochlorite. So that is 45.0 milliliters. And that's my final answer. So once you get to this answer, right, and you type it in a Sapling and you click check answer and then it says correct, most of us would probably say, okay, good, right? And move on to the next question, or say, oh, I'm done with my homework. It's time to watch Netflix. Now here is the key. Once you've done this, once you get to this point and it says correct, that's when I'm going to urge you to go back through this, right? Say, okay, let's go back through all of these steps. Why is this an M here? Why am I solving for my initial concentration? How did I solve for my initial concentration? What did I do here? What did I do here? Be able to go back through all of this to figure out, why you did what you did, and just make sure it makes sense one last time. Now this piece of paper here, right? I've got everything laid out nice and organized. I've put my units in, right? It's easy for me to follow. So this would be a great tool, right, for me to use as I prepare and as I study further, to sort of quickly review this every time I need to, have a question. That's what studying is. It's not just putting in the answer and getting, the little thing that says correct. It's going back through your work and really asking yourself, doing the metacognitive process of, do I really know this? How do I really know this? All right, that's enough